Let's break down the core idea behind this paper, DeepSeek-R1 from DeepSeek. Nobody taught this model to think. They just paid it to be right, and it taught itself to reason. No worked examples, no human solutions. Just a reward for the correct answer, and a model that slowly, on its own, started thinking longer, checking itself, and doubling its score on the hardest math in the room. Here's how everyone else taught reasoning. You collect a mountain of human-written, step-by-step solutions, and you make the model copy them, supervised fine-tuning. It works, but it's expensive, it's slow, and it quietly caps the model at human reasoning. It can only imitate the paths we already wrote down. DeepSeek made a bet. Throw that whole stage out. Start from the raw base model, skip the human demonstrations entirely, and just let reinforcement learning loose. Try an answer, get graded, do more of what worked. That's it. They call this one R1-0, zero human reasoning data. But reinforcement learning usually needs a second network, a critic, guessing how good each step is. Expensive. GRPO throws that out too. For one question, sample a whole group of answers. Score them. Then each answer's advantage is dead simple. How far above or below the group's own average did it land? Beat the pack, get pushed up, drag behind, get pushed down. The group grades itself, no critic required. And the grader is almost insultingly simple. 2 rules. 1. Is the final answer actually correct? Check it against the real solution. 2. Did you put your thinking inside the tags? That's the entire reward. Notice what's missing. Nothing tells the model how to reason. We only score whether it landed the answer. And they're blunt about it. The grade is nothing but whether the final answer is right. So what does a model do when the only thing rewarded is being right? It starts thinking longer. With zero instruction to do so, its answers stretch from a couple lines to hundreds, then thousands of tokens. It begins to backtrack, try another route, double-check itself. Reasoning wasn't programmed in. It grew because thinking longer got the answer right more often. And then, mid-solution, it did this, the model catching itself. The scoreboard backs it up. One problem, R1-0 is a genius that mumbles. Unreadable, switching between English and Chinese mid-thought. So the full R1 wraps that raw reasoning in a 4-step polish. A pinch of clean example thoughts to fix the voice, then the same reasoning RL, then keep only its best answers and fine-tune on them. Then a final RL pass for everything, safety, writing, the works. Same emergent brain, now presentable, and it ties OpenAI's O1 at 79.8. If watching a model teach itself to think is your kind of magic, like, subscribe, and send this to the friend who still thinks you need a million labeled examples for everything. Stick around, because the next part is the sneaky clever bit. R1 is a 600 billion parameter monster. Most people can't run it. So here's the gift. Take R1's answers, those long, self-checked reasoning traces, and just fine-tune a small, ordinary model on them. Plain copying. A 7, 14, 32 billion model drinks in R1's thinking. The distilled 32B hits 72.6 on AME, out-reasoning models many times its size. And here's the punchline that flips the whole story. They also tried the other way. Run that same expensive reinforcement learning directly on the small model, and let it discover reasoning from scratch. It barely budged. Turns out it's far better to let one giant model do the hard exploring, then hand the finished thoughts to the small one. Discovery is expensive, copying discovery is cheap. So the whole recipe, start from the base model, reward only the right answer, score each try against its group with GRPO, no critic, and reasoning emerges on its own, aha moment and all. Polish it in stages so it's readable, then distill those thoughts down into models you can actually run. The one-line version, don't teach a model to reason, incentivize it. Reward correct answers. Optimize with group relative reinforcement learning, and watch the chain of thought grow itself. Then copy that thinking into something small. It leaves a genuinely strange thought. If all it took was rewarding the right answer, how much reasoning was hiding in these models the whole time, just waiting for a reason to show up? That's my read. Tell me yours. Until next time.